Hello everyone. In today's lecture, I will cover three topics. Number one, linearly dependent. Number two, linearly independent. Number three, Wronskian. So, and the first topic is linearly dependent functions. The functions f1, f2, so on, fn of x are said to be linearly dependent over an interval I if and only if there exist constant c1, c2, so on, cn, not all zeros such that c1 f1 plus c2 f2 plus so on cn fn equal to 0 for all x in given interval. For example, I have considered two functions x cube and 5x cube. When you multiply these two functions with c1 equal to minus 5 and c2 equal to 1, then on adding these two functions give me 0. Look at this expression. This is minus 5 and it is denoted by c1 x cube, that is c1 f1 plus c2 f2, and c1 f1 plus c2 f2 is 0, but c1 and c2 are not zeros. Here I have written constant c1 c2, so not all zeros. If this condition holds, then we say that the functions are linearly dependent. Otherwise, they are said to be linearly independent. You have again to show that c1 f1 plus c2 f2 plus so on cn fn equal to 0 implies f1 f2 so on fn are linearly independent. Or in the other words, you can say that the functions f1 f2 so on fn of fx, a variable x, are said to be linearly independent Li over interval I if there exists constant c1 c2 so on cn such that the relation c1 f1 plus c2 f2 plus so on cn fn is equal to 0 implies c1 equal to 0, c2 equal to 0, so on cn equal to 0 for all x belongs to the interval I. Third topic is the Wronskian. What do you mean by the Wronskian? Let f1 f2 so on fn, again n functions which are real valued function over an interval I, each of which has a derivative of at least order n minus 1 over I. Then the determinant. Look at this determinant. This determinant in which the first row is of functions, original functions f1 f2 so on fn. In the second row you have established the derivative of first order and so on. In the last row you are differentiating the given functions n minus 1 times, and it is this determinant is denoted by w f1 f2 so on fn, and this determinant is called Wronskian of f1 f2 so on fn over given interval I. There are some properties of the Wronskian. The first property is, if the Wronskian of the functions f1 f2 so on fn over an interval I is non-zero, then these functions are linearly independent over I. If the functions f1 f2 so on fn are linearly dependent, then the Wronskian is 0 for all x belongs to the interval. So these were main topics. First was the linearly dependent, second was the linearly independent, and third one was the Wronskian. What we are doing here, we are actually checking the linear dependence and linearly independence of the given functions over an interval. First two definitions were based on the constants, and in the third concept, that is on the Wronskian, we have checked the linearly dependence or independence through the Wronskians. So all the students are suggested to find out the linear dependence and independence using the Wronskian. So for that I have taken one example. I have taken three functions. First one is x, second one is x cube, third one is x raised to 4. These are continuous functions over reals, and I will show that these three functions are linearly independent if x is non-zero. In earlier discussion, I have shown that the given functions are linearly independent if their Wronskian is non-zero. So I will find the Wronskian of these three functions. What I will do, in the first row, I will write only the functions. In the second row, I will write the first order derivative of this function, and third row I will write the second order derivatives and then compute the determinant. f1 is x, f2 is x cube, f3 is x raised to 4. f1 dash x means derivative of x is 1, x cube derivative 3x square, x raised to 4 has the derivative 4x cube. Again the second derivative will be 0, 6x and 12x square. When you compute this determinant, you will get 6x raised to 4. But in the question I have given you that x is not 0. When x is not 0, therefore 6x raised to 5 can never be 0. It means functions f1, f2, f3 are linearly independent. Now for the homework, I have given you a simple question. You have to show that these three functions are linearly independent using Wronskian. Thank you.